Okay. I got various questions this weekend about the problems that look like this. And while it might look a little bit complicated, it's really not so complicated when you just dive in and do it. I mean, what do we do when we want to factor this? The instructions said find all values of b that make this polynomial factorable. So we just do our diamond problem. 12 goes on top and b goes on the bottom. We need to find factor pairs that add up to b, but we don't know what b is. So let's find factor pairs like 1 and 12, -1 and -12, 3 and 4, -3 and -4, 2 and 6, and -2 and -6. What would that make b equal? Well, 1 plus 12 is 13. -1 and -12 is -13. Remember, down here is the sum. 3 plus 4 is 7, and then -7, 8, and -8. So b can be any of this set, okay? 7, I'm going to put a plus or minus 8, and plus or minus 13. Okay. Anybody have any questions on that? If you have any questions, go ahead and speak up. Okay. I'm going to go ahead and switch the page. If you want to copy down the notes from this, leave a little space, and you can copy it when you watch the YouTube video. You can fast forward to this part and pause it. Okay. The next thing we didn't go over too much was factoring sums and differences of perfect cubes. So I'm going to do 2 examples for you. They're the same ones as from the book. Now, the first term is just 2 terms, and what you do is you take the cube root of each one. The cube root of x cubed is just x, and the cube root of +1 is +1. Now, it's always going to be same, change, plus. Same means the same sign as your original problem. Same, change the sign, and then put a plus. Okay? If I'm going to look at the first term here, I know that x times the first term must equal x cubed. That makes this x squared. I know that 1 times the last term must equal +1. That gives me +1. The middle term you just have to memorize. You multiply these 2 terms, and 1 times x is x. I'm done. Let me do another one like this. Do you have a question on that one?
I'm sorry. How same change plus? How do you get it to there? You lost me. I'm sorry.
So do you understand the same change plus?
I don't understand why you change the sign and why the x squared is there.
Okay, so let's go over a few parts of it. So same change plus is just something a kid taught me to make me remember it from his own teacher. The logic behind the first term is whenever you multiply your first terms of your parentheses, it must equal the first term of the polynomial. So x times what equals x cubed? And it'll be x squared. 1 times what equals 1? First and last terms are always going to be like that. Okay? The middle term, you just have to memorize it. This times this, and you put it there. But Ivan, let's say that you don't remember this stuff, because I'm really not into memorization, but I know this term. This term's kind of easy. Cube root, cube root. I can do synthetic division on here to get the leftover polynomial. 1, 0, 0, 1, because we don't have our x squared or x term. Add down, multiply up. Add down, multiply up. Add down, multiply up. And we have to get a 0 in order for this to be a factor. We're left with 1x squared minus 1x plus 1. Exactly what we got there. It's magic. Thumb up. Good. Let's go to this one now. Instead of synthetic division, now I'm going to use my pattern. Cube root, minus cube root. So, same, change, plus. Tell me what goes in the first spot. Anyone?
$25x squared.
25x squared. Tell me what goes in the last spot. Negative 2 times what equals negative 8? 4. I saw someone hold their hands up. And to get the middle term, you just multiply each of these without worrying about the sign. 2 times 5x is 10x. Done. Okay. Now, they showed this in the book. I mean, honestly, the way I learned it back in Algebra 1 was x cubed minus y cubed would equal x plus y, x squared minus xy plus y squared. And you just figure out, well, what's your x and y? If these are cubed, you have to do cube roots. Whatever I have here, I have to square it. Whatever I have here, I have to square it. Multiply these two things and you got your middle term. So I did it straight from the formula. I learned more as I started teaching because I would hear what my students would tell me that their other teachers would tell them. So it was pretty cool. Same change plus, same change plus. This thing up here is something I did on my own. What's it called? Synthetic division. Continue. Any questions? Continuing on. Okay. So today's lesson just has some extended polynomials where you're going to do more than one kind of step. Okay. So when I look at this, for example, I can see, well, it's a cubic polynomial. So we're probably going to reduce it down to a quadratic somehow. And that's exactly what we're going to do. I see that each of these terms has a 2 as a factor, and I see there's an x in each one. I'm going to factor out a 2x. Make it a little simpler. Factoring out means dividing, and when I divide 2 by 2, I get 1. X cubed divided by x is x squared. 8 divided by 2 is 4, and we're counting down powers. You can see it. We did 3, 2, 1. It's going to be 2, 1, 0. 0 is without an x term there. Now, by now, I hope you guys can factor basic trinomials like this. I'm not going to go through the entire diamond. It's going to be x plus 2, x plus 2. And these are the same, so I could rewrite it as x plus 2 squared. Give me a thumbs up, thumbs down, thumbs sideways. If you're having trouble seeing my camera, be sure to pin my camera on your screen so it takes up the whole screen. Okay. You can either take a picture of it or you can leave some space and you'll have a chance to do this later. Right now, I want you to do the following problem, which is very similar. Can you see it down here? 3x cubed minus 30x squared plus 75x. Everyone go ahead and factor that. Okay, what's the greatest common factor? 3. How about a variable? Yeah, 3x. Don't be afraid to speak up. Nobody knows who's speaking on this video. If I divide out 3x squared, 3x from here, we're left with x squared. Divided 3x here, we get minus 10x. And divided 3x here, we get plus 25. When I factor this trinomial, I get x minus 5 times x minus 5. And that gives us 3x times x minus 5 quantity squared. Beautiful. Did I do it right? Check my work. Can you do this on an exam? Give me a thumbs up, thumbs down, thumbs sideways. Okay, good. And this will be like 3 points. Take a picture of it if you like. I'm going to move on. Or you can go back to the YouTube video after I upload it. It'll be posted for tonight's homework. Any questions before I remove the page? Now we've got some strange ones that we got to go over. We've got some rational exponents here. And the way you're going to do these is you're going to look for a common factor and you're going to factor out the one with the lower exponent. Okay? I see an x plus 1 in both of these. What's the lower of the two exponents? Go ahead and speak up, somebody. What is the lesser of the two exponents? Lower number.
Negative 3/4.
Negative 3/4 is correct. I'm going to write it out here because I'm factoring it out. And on the inside of the parentheses, I'm going to actually write all the work because this is a little confusing with this exponent. So I'm going to write my first term. And I'm going to write the factor that I'm factoring out on the bottom. This is the same thing we did in the last problems, but we did it in our head. Over here, I'm going to do the same thing. And whatever I'm dividing out is going to go on the bottom. Now, for this next step, I need everybody's eyes on the screen and watch what I do. Let's not copy for a moment. Everybody's eyes on the screen, just to watch what I do. I'll pause for a minute after for you to copy. Everybody watch? So these two cancel out because they're the same. That leaves me with x over here. On this one, I see a common base, so I have to subtract exponents. What's 1/4 take away negative 3/4? 1/4 take away negative 3/4.
Negative 2/4 or a half.
Let's try it. Let's see. 1/4 take away negative 3/4. Minus a negative means plus plus. Do you want to try again?
4/4.
4/4, which is 1.
Yeah.
So this is x plus 1 to the first. And that's why I wrote everything out, because it's really difficult to keep track of everything. You can remember that I told you negative exponents go to the other level to become positive. So you can imagine the 3/4 being up here together with the 1/4 and making 1. Now let's simplify the inside. We get 2x plus 1. And this negative exponent just means it goes on the bottom. X plus 1 to the 3/4. And this is all they want for the answer. Okay? That's it. The reason for doing it this way is because later in calculus, you'll be doing stuff like this. And basically this fraction on the bottom is going to start disappearing when you do limits. Go ahead, I'll give you a minute to Copy that down. Okay, I'm going to move the paper up. I have a problem for you to do like this one. Can you guys see it right here? Okay. X times quantity x minus 1 to the negative 1/2 plus quantity of x minus 1 to the 1/2. Factor that one. Okay, what is the smaller of the two exponents? Is it the 1/2 or the negative 1/2?
Negative 1/2.
Negative 1/2. That's what I'm going to factor out. I'm going to rewrite the rest with my x minus 1 to the negative 1/2 on the bottom, because that's what I'm factoring out. Factoring is the same as dividing out. I'm left with this whole term on top and this whole term on top. Okay. Cancel, and that leaves me with x. What's 1/2 take away negative 1/2? I see a possible 0. Let's try it like we did earlier. 1/2 take away negative 1/2. I see a 1. That's right. It's always going to become 0, 1, or 2, basically. Bring this other side down. And I'm left with 2x minus 1. Because this to the first, I can get rid of the parentheses. And on the bottom, x minus 1 to the negative 1/2. What did I do wrong? Find my mistake.
You put the exponent that it's still negative, but it's on the bottom already.
Correct. So this should have been positive because when I moved this down here, it became positive. There's your answer. You think you can do these on the homework? Okay, does anyone have a question? Okay, I'm going to stop the recording right now.